Cool. Now we are live. Great. So I'll just say that thanks everybody for coming. I'm going to hand over to Jørgen in a second. I was just going to say, though, it is a discussion, so feel free to ask questions, raise your hand, write in the chat here, or as well write in the chat in the Slack channel as well, and we'll pick up on things as we go. But other than that, I'll hand over to Jørgen.
Yeah, Steve, in case I should miss it, if there's a sort of pertinent or very topic immediate question that pops in, I might not notice it right away. Could you please moderate and interrupt? Interruptions are fine, but if it's something I'm talking about right now, then I'd rather have the question right now than at the end when there's no context.
Yeah.
So okay. I'm actually going to start off because we had some questions in advance from Robert Schmidt, which were excellent. And I figure we'll start with a couple of those. So actually, we should probably start with the introduction of what Oneseismic really is. Okay.
Yeah.
So Oneseismic is my latest project in an attempt to make seismic less obnoxious to work with. Seismic is actually pretty curious in that sense. It's peculiar even because at least when it's processed into 2D or 3D, it's actually pretty simple data with the only difficult property about it is its size, right? So what Oneseismic does is it sort of removes itself a little bit from the physical space, and it considers all seismic just a regularly spaced out Cartesian grid, really. And it turns out that allows us to do quite a few interesting things. That manifests itself as really an API endpoint, if you will, or a sort of database interface. And if you're going to have a good definition of it, would be that it's really just a database. It's a database technology to rival something, I don't know, like Postgres. Not really, because we're trying to compete or even compare ourselves with Postgres, which is an excellent project. But that's the sort of mindset you need to think about it as, or that's the kind of problems it solves. Behind it is a distributed system. But I think the innovation or the project here even should be summarized and considered just the interface, the query interface. So it's based on a couple of assumptions. One is that effects in seismic are what I would consider reasonably local. Okay. I think part of it stems from the physical properties of rock. A lot of signals don't tend to propagate very far in the lateral direction, right? So something you do on your trace n, it's probably not going to affect whatever you see on trace n plus k for some k that's reasonably small, right? So for most algorithms, you're not really particularly concerned about anything outside of your immediate vicinity. I'm sure there are exceptions to that, but in general, what I've seen, that seems to be true. That gives us opportunities, yes.
And you're talking about post-stack there, then?
Yes. Yeah. Almost all of this is post-stack, because obviously pre-stack, anything goes. When you're well, stacking, I mean, whatever information you take in there, not really of the concern. This is targeting primarily post-stack. So some kinds of pre-stack data, because I mean, what does pre-stack even mean, right? It's a pretty wide range of data that would all be considered pre-stack. And so when you have your regular cubes, but with just offsets, that's still pre-stack, but it's so close to stack that you might as well consider it that, right? So for that kind of pre-stack, we would work pretty well because it's really just a properly stacked cube, but with sort of ghosts or parallel artifacts. But in general, Oneseismic for now is targeting post-stack data. So you're working on nicely, spaced out 3D volumes. On top of that, we kind of boot the physics out. So stuff like angles and skew and, locally compression in terms of how close traces are, we don't care. We treat it as an n by m by k grid, right? So that gives us huge opportunities for optimization, assuming what you care about is, again, reasonably local. So I'm gonna do some screen sharing now. Let's see, just entire screen. Because I just want to go briefly over why it works. Okay, so you have to apologize for my drawing because I'm not very good at it. Also, I lost my mouse pointer for some reason. There we go. So this is the volume, but just seen from above. I'm going to do drawings in 2D because they're much easier to do in 2D, but it translates pretty well to 3D, whatever you want to do, right? This was very difficult with no mouse pointer. I don't know why it's gone. Right. So what we do is that we take the volume and we partition it into this equally spaced grid. So we partition it into equally sized subvolumes. We call them fragments in our internal vocabulary, right? But I mean, you can call them subcubes. You can really refer to them as whatever. Voxels. They're voxels, right? So this would obviously be in 3D. And what it turns out is that if what you care about locally, most of what you care about locally will be in a pretty small band of these. So let's see, can I change the color? Right. So, for instance, if you want an inline slice, all the data you care about is in this band here, right? And this is the main property for speed in Oneseismic, right? It's that it knows that you care about a very little band, and so it partitions the volumes and stores them in these voxels, so that when it interprets your query, it knows exactly what voxels would properly contain whatever you're asking about, and then it just slices from this much smaller fetch. That reduces the pressure tremendously on the I/O. On top of that, in practice, this is backed by a cloud system, right? But in theory, you could do this on a local disk as well, and you will see significant speedups. Yeah. So I prepared a notebook, and I figured we're going to start from complete scratch here just to get a feel of what it really means in practice. And for reference, I have a file here. Where this file is about 8 gigabytes, right? So what I'm going to do is I'm going to just do timing on this. And I'm just going to print the sum just to show that that it does something, right? So we started this. This is from a local disk, right? And what I'm doing is I'm just taking the 150th SED time slice for this entire volume. This is one of the worst things you can possibly do with SEG-Y, right? Because it's type. It's all linear. And what I want to do is I want to compare this to a similarly sized volume in Oneseismic. This is an internal test volume that we have, which is about 10 gigs in size. Okay. And we're going to start simple. So I'm going to have to type a little bit now. I'm going to turn the microphone off. So for about 10 seconds.
Okay.
There we go. It didn't actually print the time, so that was a fluke. So this is the absolutely or easiest way to get started. Now, this is part of the Python support suite that would ring up our cluster, and it tries to be as low effort to get started as possible. And if you just want to do something simple, this is fine. Okay, you can turn and twist a lot of knobs in the system, but they would complicate the simple or any client so much that we're decided to completely split out the absolutely trivial stuff from here. You need control anyway, so you might as well do it directly. So you get this, which gives us back a process, right? And this process we can render into a NumPy array and just, I guess, print it, right? So you see the other one's still going, so we'll have to wait. So there we go. It took 83. Oh, hang on. Isn't it? Let's just see proc then. Right. Oh yeah, it's of course. My bad. So we need to authenticate. These tokens for authentication, I can talk forever about them, but they're not really that interesting for our purposes. See, this gives us a simple result, which can in turn be rendered to NumPy. So let's time that actually from the start, shall we? And then let's just do, I guess, sum. Obviously, the sum will be different because it's a different volume. We can see here that we managed to get a depth slice from a larger volume in virtually no time. And honestly, this is part of the value proposition in Oneseismic, is that you can now get the data that you do care about without having to muck about with, parsing SEG-Ys and sending massive files about. You can get it in literal milliseconds with just a couple of lines of code. This is it. This is what we do. This uses a lot of nifty tricks and implementation and hacks. Well, not so many hacks anymore, but lots of tricks and implementation and infrastructure in order to make this happen, right? But this is the value proposition, is you can ask for pretty much any, well, right now we only support a handful of queries, but you can ask for interesting shapes and geometries in no time.
What is backing that then?
So it is right now, this sort of test deployment, if you will, is backed by 4 or 5 virtual machines and the Microsoft Azure Blob Store. And they run software written largely by me.
Okay.
So most of it is custom. And I think that's a good time to bring in some of the questions, because now we're sort of getting into some of the whys and the motivations, right? So, hi, Robert Schmidt. So OSDU has a couple of post-SEG-Y initiatives already, OpenVDS from Blueware and OpenSEG-Y from Schlumberger. How does Oneseismic relate and compare? So, first of all, I would like to point out that Oneseismic is not really a competitor to SEG-Y. SEG-Y has unfortunately been used as a processing and working format for a lot of seismic data. I think that is slightly unfortunate because that's not really its intention. It's an interchange format. I would be the first to rip on SEG-Y, but for that job, it has a lot of properties that makes it pretty suitable. Right? It is meant for vendors and partners to bring literal rolls of tape to each other. Here's the data, load it into whatever format you have. Right? Oneseismic specifically tries not really to be a format, although it uses some formatting, like data format tricks, to be fast. But it's not primarily a data format. It's primarily this query thing, right? That being said, it is similar to OpenVDS in a way. OpenSEG-Y is not new by Schlumberger. But it uses some of the same tricks and same model. Although both OpenSEG-Y, as far as I know, is compressed, which means it's lossy. This is full resolution, as it was in the SEG-Y. So in most cases, 4-byte float, right? So no compression, not in storage and not in transport. But it's similar in the sense that it tries to block up the data and have individually addressable units that are voxels in the larger volume that can then be addressed, right? So you have to read much less data in order to actually get something out. OpenVDS from Blueware is in a way similar, but both of them have the problem is that they're still almost file-oriented, right? So I know OpenVDS can be read from the cloud, but their client is very sort of trace and column-oriented, whereas Oneseismic tries, and it's a C++ library, or with its Python bindings, that you're meant to embed into your application. Oneseismic doesn't try to be embeddable into an application. It's meant to be something that you just run from sort of user space, and to you consider more of a service than as something that you embed into you, right? And this is pretty cool too, because that means you can write task jobs where you issue different queries to your different worker nodes, and they all just get the data they need and only the data they need, which is pretty neat. So I think Oneseismic tries to solve a different problem than OpenVDS and OpenSEG-Y, right? It doesn't try to solve the problem of the file format. It tries to solve the problem of the service. We'll get to that into queries in a wee bit. So and then there's just Oneseismic support more esoteric variants, for example, 2D and 4D surveys, pre-stack, offset gathers. The underlying framework, I would say, is there. But right now, 3D post-stack volumes is by far the most tested path. So I would argue that some 4D surveys in particular, you are better off implementing as a series of 3D surveys, and then you tie them together at the query level, right? So one thing you can notice here is that the way to address an object in Oneseismic is through this long ID. Eventually, you will have a catalog either in your app, or maybe you can query Oneseismic for it. But sort of this is the key. This is a unique identifier, right? And if you know you have your 4D survey, which means that you have 5 volumes that have the same dimensions, you run this one, right? Or rather, you run this query here, but you replace this ID every time. Then you can do your queries over 4 dimensions, right? And what that means is that in the case of the simple client, you would just fix these 2 parameters and you would vary the ID. But on deep down, it supports n-dimensional data actually. And 2D is, you can argue 2D is just a special case of 3D where one of the dimension is 1, right? So that too should work just fine. Is the round trip from SEG-Y to Oneseismic to SEG-Y lossless? So we aren't actually round trip lossless at all. We don't care about outputting SEG-Y. We throw away most of the header data. We don't care about it. So you can't reconstruct a SEG-Y, but we store the traces lossless after IBM to IEEE translation. So if it's IBM floats, then there are some values that will not be lossless anyway, right? Because of just format differences. Varying inline trace length. So what we do there is that we pretty much we make a bounding box around the volume, right? And if the traces vary in length, then some of them will just be padded. We don't really have good support for the sample size or sample rates in that case, but that's something that we're working on. The underlying bulk storage mechanism and granularity. Right now, all of the data are stored in blobs. Each fragment is a single blob. Each holistic volume is stored under one storage container, and that's really it. Although we are independent of the storage of the account in Azure terms, so you can have as many accounts as you'd like, and the underlying infra can handle that just fine. And then finally, is Oneseismic limited to physically persisted array of samples, or is the notion of lazy compute with caching and pluggable algorithms? Well, actually, I could read that a bit slower. So is Oneseismic limited to A, physically persisted arrays of samples? Kinda, yes. I would say yes. Because there is no notion of compute in Oneseismic. Oneseismic tries to solve one problem and solve it well. It is the query large bodies of seismic for small subsets problem, right? Compute is something that you bring yourself. Dask is a pretty natural tool there. And then Dask would do caching. That being said, Oneseismic does a lot of caching now. So for instance, if you would do, or I say now, it's a pretty recent feature. So if I take this, right, and indent blocks in this, I don't know, and just run it 15 times, and you can see the response time just drops, right? Because now more of the requests are, of the underlying fetches are cached, so you get pretty good. And this is a depth slice, by the way, which means that this is the one that took 84 seconds in SEG-Y. But yeah, there is no notion of compute in Oneseismic. So building compute on top of Oneseismic isn't too difficult to do, but Oneseismic tries to just deliver seismic.
Does it? Because one of the things about when you start building compute on top of something, like this, is imagine I want to compute an attribute or some type of measurement, across that depth slice or on a horizon. I need a subvolume around that horizon in order to compute it. So that's one thing. I need to fetch more data than is required, and then once you get up to large scales, you want to distribute that. And then you want to deal with things like block overlapping. So I think in Dask it does ghosting to sort of support this.
Yeah.
Does Seismic? Oneseismic doesn't do anything about that at the moment, or attempt to.
No, it does
serve redundant data back in a way that's nice.
So yes and no. With caching of the underlying fragments, you can see even querying large data here. The second, third time will be so fast that you can just query again. But it's because it's something that is largely interesting to handle in the application. Now, one thing we consider adding are queries that allow you to specify halos. So say you have a horizon and you want 10 samples up and 10 samples down. Along that horizon, you would basically get this block, right? That is not straight. And then you could specify that horizon once and just have the entire thing delivered to you as a block, right? But I think that's something that you would want to distribute, or something you would rather specifically handle in your application where you have more information. We try and be a pretty dumb data store in that sense. So I would say largely no. I would say, so for because you have your question here, Steve, is the intention to return data derived from the seismic, like attributes or other calculations. So I think if you are able to fetch data fast enough, computing some attributes like differences and sums should be sufficiently fast that you shouldn't need to cache it. The only reason you would need to cache it is because your I/O is too slow, right? But if you can get your data from both sources, including transport, in 200 milliseconds, you wouldn't care to cache it. You would just compute it and be done, right?
Yeah.
But
Cool.
if you want to do that for a full cube, a sort of difference cube or something like that, or even a time-shifted cube, is still just a volume, right? So you can just upload that into Oneseismic like any other one, assuming you have write permissions, right?
Yeah.
So I would say that most computations you will want to do on the fly and outside of Oneseismic.
Cool.
Okay.
Yeah. Sort of related to that then, and maybe a better question is, have you sort of explored any use cases or worked with anybody who's used Oneseismic to actually fetch for a job that's running on a Dask cluster?
We haven't. We had some when Matteo was still at Equinor. He did some. He did some time shifting stuff on a Dask cluster with a very primitive year ago version of Oneseismic. And in his case, it dramatically simplified the implementation. And I think it was a factor 50 something speed up at the time compared to the straightforward implementation that he had at the time. Now it would be much, 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 much better to do that for him. So we had a few of those, but it's sort of the big momentum really isn't there yet, unfortunately.
Okay.
I have some, of course, of my own tests that are pretty easy to do, right? But they're just not too many other people have experimented with that, because honestly, the public, if you will, demo hasn't been out for all that long. So it makes sense.
Yeah. Cool.
Let's see. I think maybe there's another question here. Let's see. No. Okay. So this simple client it's very simple. It's very good for doing that one thing and doing that one thing very fast. You can do some other. So Oneseismic tries to primarily be a source for seismic traces, right? But in order to make sense of those, you need to still do some other things, right? So the simple client has one that's called Metadata, which I think just does all of it. I think that's it. Oh yeah, and so I'm gonna show the Volva now. Scroll down a bit. Right. So we have that, and then you can do. It's called metadata. This just returns all of it. It is a little bit noisy, so please bear with me. And then it's Volva and ID. So this is Volva. It is publicly available, but you need a token which you can ask for and we will issue. See, and here you can see some metadata for the cube. It has your line numbers, which is just obnoxious. So let's do that, and it's called line numbers, I think, with line numbers, and then like that. Right. You can see it has the file name when it was uploaded. So this is, you can actually learn a lot. This is why we included the file name, which is something that we generally try and distance ourselves from, because Oneseismic doesn't have a concept of file names. It has IDs, right? But very often, a lot of information is encoded in the file name. So it's something that we made available as a sort of quality control mechanism, or quality assurance, rather. so that you're absolutely sure you're working on the right volume. So this is the something migrated final post-stack 3D from Volva. Okay. But you can also ask for you can get the line numbers this way. Okay. So that's pretty neat. For the Python client, if we go back to, actually, let's get a new one. So if we do dot, and then we can do slice by index. Again, I use index because it's simpler. But you can also do by line numbers if you already have the line numbers. We want to support looking up coordinates directly with some snapping logic, but that isn't supported yet because it's a little bit of a hairy problem. ID dimension is 0, so we do an inline, and we do let's do 150, which is somewhere in the middle, right? Let me look it up. Right, and now we can do X-ray on that, which is pretty cool. X-ray is very beefy, right? So here you can see the client library actually gets enough information that it can populate the coordinate axis properly in the inline or in the slice case. You see, so this is actually inline slice 10111. So a little bit dull, so let's do 60. And let's also get some attributes. I think this is it. So let's get the CDP, which X-ray also knows how to get. So here you can actually post, download, filter on the CDP X and Y. We want to add more of these, especially those that are easily-ish derivable from the SEG-Y that we ingest. But this is pretty cool. What also that means that we can do is that we can plot. So it's I think it's that. Yeah. Oh. Can anyone know how to left transpose? I don't know how you do that.
Flip left right, but that's not X-ray.
No, that didn't work. Anyway, so it's upside down, but hopefully, oh, is it sort of set axis or something? I don't know.
I don't know the other way.
It's
X-ray, sorry.
Pardon?
I don't know an X-ray.
I think it's this matplotlib too. So I guess you can just do, I don't know.
Invert y-axis equals true.
Oh, is it
invert underscore y-axis equals true? Maybe.
No.
No.
I don't know. If anyone knows, then just give me a ping, please. Because, but anyway, you can see that you can even plot it. It's just such a breeze, right? And this is done in absolutely no time. This is something that lives in the Python client, but it's also something that's pretty easy to do, even from just a raw reconstructed query, which you can do for either direction. One thing, so now I'm showing slices, and slices to me have always been very interesting because they have all the worst properties in terms of data access that you can imagine, but they're easy to represent and reference to because it's two numbers, right? Problem is that usually we want to support querying slightly more sophisticated data, right? And slices obviously have limitations, but for instance, say you want to follow a well path, right? So what I can do is that I can make a well path. I should have maybe made this one in advance of just some indices, right? So let's say it's 10, 5, 10, 6, 11, 7, 11, 8. I don't know what kind of well this is. And then 12, 9. So it's pretty diagonal, right? So now we have our path. What we can do, again, this is partially powered by the Python library, but it's also pretty easy to do just directly. We'll pop onto the query language in just a little bit. Is that you can do, we call it curtain by index. We still do vulva, right? And then the path. Right? Let's see. Oh. Is it? You'll have to excuse me. I do get a new one. There we go. Okay, so it's it has it's curtain by index. Oh no, that should be it. Oh, okay. So there's a tiny problem there in the client. Okay, but that means it's time to start making some queries directly. So all of this now has been through our Python client, right? Unfortunately, it gives a pretty weak understanding, this Python client, of what is actually going on. So what I've done is I've prepared some code in advance that pretty much does this by hand, right? So I actually have, for testing purposes, I have a shell script that does this. So what we can do is that we can write this query. This query is in a language called GraphQL, which is made by Facebook and released 6-7 years ago or something. We picked GraphQL because it had a lot of appealing properties, as well as just production-ready implementations that we could steal, because we didn't want to implement our own language engine, right? But what we simply do is we create this post request with this query. You can see it reads pretty naturally, right? So select a cube with this some ID. And from that cube, select the properties, file name on upload, sample value min, and sample value max, provided it has them, right? And so you make a body of that. And what you get back is, we need to import requests. And there's another problem, which is the URL. And the URL is, let's see, it's vulva URL /GraphQL, and then we need our authorization there. And sus. This is a little bit cheeky way of making addresses, but there we go. Right, and see what we get back is the original file name. So this is what the client does under the hood, right? And honestly, I think this doesn't even read too bad. So if you have fairly simple requests, but you want to render this based on user input, you can do that directly and it will be perfectly fine. Okay. Say now you want some data. So what you do is that you, well, I guess copy pretty much the same thing, right? But here, instead of file name on upload, you also ask for the slice or curtain by index, right? And here you can see that then we need more. So we do index, well, curtain, right? And I think I call them intersections, which is a list of int. So that's one too many. Right? File name on upload, nothing, but curtain by index has intersections. Right? And here now we do our path, right? Chords. It's chords. Right. So what we get out here is this dictionary, this response, really. And our curtain by index, you see this maps to just the output direct, or the query directly. So you see data cube. Data is just a generic by protocol name of the response, if there's data in there. So it's cube from here. And you can see the file name on upload. That's there. Then it's the curtain by index. Now, this is our special internal type, which is called a promise, which maps, or it's just analogous to the promise from any other programming language, right? Or asynchronous programming. And so this doesn't give you the result directly because it could be too slow. It could, because if you ask something humongous, then this will block. And also, clients really want this to be JSON, and encoding binary in JSON is just terrible. So instead, what we do is just give you a link to the result, right? And again, I'm going to cheat a little bit because I've written this before. We implement unpack and decode, right? Just move it up there. Which then allows us to look at the process, I think, more clearly. Right? Curtain by index. Oh. And here you see we can hydrate it into this Python native process object. And from this, we can just decode it by fetching it, right? So what we do is we make another request to actually fetch it, which means that every fetch of data is a two-step process. This is by design. And what you get back is just a bunch of data, right? Isn't that beautiful? Now, what I've done here is that I've actually by hand written one of these queries. I've made two posts, well, one post and one GET request, and I've gotten back actual data in less time actually than it took to read the set slice from SEG-Y, right? And it's just fast and easy, and I think this is the future of seismic. Something like this anyway. Cool. There we go. Invert y-axis.
Oh, but that's on the plot object. Yeah,
yes.
The axis object. I don't know how to get the axis object.
Oh, really? I'm pretty sure that the plotting has a function to do the inversion. In X-ray, I just can't remember the key, and it's weird looking it up.
Yeah, I think it's a weird one. Anyway.
Yeah. Yes.
So great. So is this, because I was wondering, this is all, it's all fast and it's all read?
Yes. So one of the underlying assumptions is that most data is really read-only, right? And we can do, for instance, caching is a breeze when you know that in a healthy system, data isn't overwritten. So the reason that works is that we compute a unique ID for every volume that you do upload or ingest, right?
Yeah.
Excuse me. And that means that if if you want to add more data to this system that you can then query, it will always get a unique new ID. It will never ever collide unless the data is identical, in which case you already have it, so there's no point uploading it, right? So because of that, that aspect is read, right? What you get with the data back and then do with it, if you compute something, I mean, that's all up to you, right?
Yeah.
But the system as a whole is not read-only. I mean, obviously, we're able to put data in there. And in fact, we have projects where sort of 90% of the job is to get data into Oneseismic so that users can query it. So from a query perspective, yes, this is all read, right? But putting data in there is certainly possible, and it's something that you can just do.
And what's that process like? Because I posted a couple of questions in terms of, does that take time? Because is the volume bricked or split up or duplicated? And
right.
The second thing is there bloat, as in, do you need n times the disk space?
So yes, it takes time. Right now, because this is a pretty immature aspect of Oneseismic as a system, largely because it suits developer needs. But what you do is that you run two programs, one that is called scan and one that is called upload, which effectively walks the input SEG-Y, and we only support input from SEG-Y now, although that can change in the future, right? It walks it twice, once to map out all these sort of geometry and properties, and one to actually brick it up and upload it. So that takes as long as reading it takes, and often we want to do that sort of blob to blob. On top of that, since you can't restore the SEG-Y, I think the SEG-Y is something you want to keep around for archiving purposes, for reference purposes. So maybe you want to put it in glacial storage, but you never ever want to delete it, right? And honestly, everyone are so paranoid in this industry anyway that no one deletes anything. So this is a problem that you just have. This makes a fresh copy, and it makes a lossless copy. So it's about as large as your data, right? But we throw away most of the headers. Because we're assuming that source resolution is interesting. Obviously, if everything you want to do is just visualization, you don't care about source resolution. You could clip it to 8-bit and it would still look the same, pretty much. But if you want to do maths on it, you desperately care about source resolution, right?
Yeah. In terms of the data representation, the sample size, as it were.
Yeah, exactly.
Yeah.
So, and the way I like to think about it is Oneseismic is a programming environment first, or it's a programming first system, which means that programming against Oneseismic is always intended to be the first class citizen, which we've had so much pushback from that because everyone just wants to visualize something and don't realize that in order to visualize something interesting, you often need to compute it first, and that requires source resolution. And the cost of that is space and time. I mean, I'm sorry, but that's just physics, right?
Yeah. I think.
Sorry.
Some of the other formats, and I think maybe this one was a SEG-Y, and certainly some of the bricked formats around things like Open Inventor and some of the other sort of visualization packages, they sort of dealt with multi-resolution as well, though.
Yes.
And being able to query decimated just because you've got more samples and pixels.
Yeah.
A lot of the time.
So what I think they generally do is they run a wavelet through. And doing that is really what JPEG does. It allows you to sort of progressively increase the resolution as you read more of that, which is great if what you want to do is primarily draw it, right? That also means that you can't random access in the middle of the volume across without having to decode effectively the entire thing, right? So for a sort of general geometry-aware querying system, that's suboptimal, right? I think. Now, maybe the space savings would be worth it. That could be true. Or it's certainly possible. It's just I'm not convinced yet. And if this is fast enough, it's also so much simpler. And you need the source resolution at some point anyway, right? So if we can serve it, then.
Yeah, like I said, you can serve it and then decimate it out on the client. If you only want every 8th sample, then you might as well do that.
Right, exactly.
If it's fast to retrieve.
Right, or even in this case, what you might want to do is that if you know that you're just going to draw it and decimation is fine, then we can add queries that allow you to decimate at the query level, right? So next question, time to available. I mean, it depends on the upload speed and that. I think I uploaded all of Volva, which is everything that's available there. I think that from start to finish, but with parallel, took maybe 15-20 minutes, something like that. So not great, but not bad, I guess. Definitely an instance. So total space, I mean, 1 gig volume is 1 gig storage, pretty much. Yeah. I think that was pretty much all I wanted to cover, and that came enough questions. Yeah.
I think that was great. The last question I've got there is like you said, it wasn't intended to be in embedded in an application. It is for the sort of user space. But
yes,
is what type of user? So this is actually people using it in notebooks on local processing scripts.
For example,
who are programming themselves, basically, setting up custom pipelines.
Well, so what I didn't, one of the problems, sort of the user story problem, I think with both SEG-Y and OpenVDS, is that what you need to do is that you need to basically well, definitely in OpenVDS, maybe to a lesser extent in SEG-Y actually, but you need to basically manually select your blocks, get your traces, and from there basically, compute ahead of time the path that you want to follow on your well and all that, right? But with the idea with Oneseismic is that you should just be able to specify the shape of whatever you care about, and then you will just get the data back in that shape, right? So you wouldn't have to do the manual, download a block, follow the trace, unpack the trace, blah, 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 all that nonsense. We wanted to make it more declarative, if you will. Like SQL is declarative, right? So we wanted to take some of the machinery out. Not to say that Oneseismic isn't useful in applications, because I think it is. It could power, you could use it embedded in Petrel. You could embed it in whatever viewer you have. It could power all of those things, no problem. The thing is, they still want the programming interface. But this is also useful outside of that. It is useful in notebooks. It's useful in just some checking script. It's useful for desk jobs. You can use it because it's programming first, right? Means that we don't try and take the shortcut that would compromise programmability for some immediate, viz need, right? So I think there's a little bit of philosophy there, but yeah. So, but primarily, what we want to be essentially just a kind of connection that you do to a database. So, for instance, in OpenVDS, honestly, I don't really know if it's true now, but it was true a year ago. What you needed to do is essentially use them as a download manager system to fetch blobs from AWS, right? Or buckets from AWS, S3. Whereas with us, you don't really notice that it's Azure powering it, right? At all. What you see is our endpoint and then some query string, and that's it. So I think that's the main difference, and the goal is for it to be easy enough to be in your mom and pop notebook, right?
Cool.
Which I did here, hopefully.
Yeah. So what's on so in terms of the Oneseismic package, that's the client and it's also the backend service?
We distribute the Python code, and the ingestion programs, scan and upload, are also written in Python and are included in the package, although they're not really meant for just anyone to use. They're pretty clunky, and they will be revised heavily now, like broken up. And for instance, one of the things I do want to see is to have this sort of ingest service where you basically, so say you already have copied your SEG-Y to some cloud storage. What you can do is you can just give this ingest service a link to that, and it will just pull from that and put it into Oneseismic storage, right? And it would scan what it needs to do and ask for feedback if it has to, right? So that is one of the things that I want to see happen, and for that you need the upload system to have some support. Oneseismic is usable outside of Python, and it's usable outside of outside of Python, really. So the Python client is just, we assume that most of our users want to do this from Python, right? So we provide extra support for them, but we have decoding because we use our custom binary protocol to transfer data to the end user. We have one that works in JavaScript, so you can embed it in your web app directly and decode client side, which is just a massive speed gain in almost any case, right?
Yeah.
As I mentioned, I run this from a shell script, right? You can, because it's just off the shelf, almost everything. Just off the shelf GraphQL. It's something special, which I think is just a huge benefit, and it's just such an easy design to work with.
Cool.
But yes, so the Oneseismic Python package does include the upload stuff, not the backend though, because that's in Go and C++ mostly.
Okay. But the backend stuff, is that available open source?
Yeah, it's AGPL.
Yeah, okay.
So you can get it on github.com/equinor/oneseismic. You can see all the source code.
Yeah. Right. Okay. And then you're running this on Azure, but if somebody was to want to bring it up on AWS or on Google, then it's pretty straightforward because you're just using whatever.
Yes. So we haven't implemented sort of generic interfaces for arbitrary cloud backends or even file backends. But I think, for instance, one thing you can do pretty easily is you can build a physical Oneseismic sort of server system with just a bunch of network cards and fast disks, and so getting it to work on a non-Azure backend is not difficult. You need to replace 2 or 3 function calls with from Azure to whatever, and maybe a little bit of link rendering, but that too isn't too bad. So most of the system doesn't care about Azure at all. But since that's our only backend and that's what we have to work with anyway, we haven't really bothered trying to generalize over it, but it's not very difficult. It's pretty contained.
Cool.
Yeah, but I mean, if you want to have it work on something else, then go ham, right? It's it should work pretty well.
Cool. But there are no other questions. The only one I had was so what's next, or what's the next big step?
I think that the next sort of short-term step is to make caching work properly. That there are huge speed ups in caching. So we're having some struggles right now with infrastructure. We're not getting it to be as fast as we'd like it to be, throughput-wise, internally in the cluster, on the cluster, and whatnot. Right? We're not seeing the numbers that we expected to see, and something is wrong. If it's the configuration, if it's the hardware, we don't know. Caching both takes some of those problems away and make them glaringly obvious. It's very interesting. So that's the immediate one. I guess the next, it's not really a big step either, but right now we support 2 kinds of queries. We support the slice in either dimension, and we support what we call the curtain, which is primarily meant to follow well paths, but it's really just an arbitrary set of XY points with an implicit full depth trace, right? So you can use it to follow some other interesting structure too. I think the next call to be added would be the horizon, right? Because that too is pretty interesting, and especially when you're working with 4D stuff. So you can do amplitude maps and whatnot over horizons. So that would be one. I think just more and better Python support, because that was quite recently reworked into this system, which I like much better than what we had. I think powerful ingestion would be one. More speed, obviously. Hang on, there was one more thing. Oh yeah, cataloging. So right now, it's just all it's all magic GUIDs and stuff, right? So long hashes and strings, just horrible to work with. But What we want to provide at some point is a catalog, so you can basically do a reverse lookup. So you can do something to get that ID based on, for instance, where on earth is this, right? So you give it lat long, and you say, give me all the surveys that or is at this point, right, or cover this point, which would increase usability quite significantly. So right now, you essentially need to provide that information yourself by mapping whatever interesting areas you have to these keys. Eventually, we would like that to be a lot easier. So the reverse lookup, but that's far in the future, I think. Well, far, maybe a year.
Okay. Cool. So how many people work on this? Is it this just you? Is it or is there a bigger team?
Up until now, people have been coming and going a bit. Effectively, it's just been me and one colleague of mine, Sveinung. And now, just recently, we got a couple of people more on the team. So we're trying to establish it in the org so that it will, sustain. But it's largely been me.
Okay, cool. I guess establishing in the org for a project like this in Equinor, does that mean getting enough pool or getting enough other projects actually using it?
Yeah, users, funding, politics.
Okay.
Yeah.
That's all three. Yeah. Cool.
All right.
Well, we can leave it there. It's been great.
Yeah.
To see. The keyboard wasn't too bad. I think.
I'm glad.
The mic. Did a good job of filtering things out.
Yeah.
I think. But it's good to see how easy it is to use.
Yeah.
And in terms of the documentation and things like that.
Yeah. So that's obviously an area that always could be improved. Most of the documentation for code is in sort of doc strings, so you can, if you want to, you can pretty easily catalog that. But I mean, you saw me doing. I can even show it. Hello, I sent someone new.
Yeah, Robert, I think, has joined. Yeah. Robert, you were asking some of the questions earlier in the channel.
So one thing you can do is you can do help, right, in the notebook, and then you'll get this. And this is almost as good as it gets, although it's not very good yet because there's no complete document that describe the philosophy. And I think a lot of things become a lot more natural once you grasp the basic philosophy and goal of Oneseismic, right? So I try here and explain a little bit on the philosophy of the simple client itself. So it tends to be useful for small and test programs, not when you need to tune knobs. For instance, one of the things GraphQL allows you to do is to ask for a lot of data in the same query. You can ask, but it's limited, so that you can only ask for instance, slices. You can only ask for one slice, but you can ask for both a slice and a curtain in the same query and all the metadata you'd like, right? Because it's a query line. It's like in SQL, right? You just select whatever columns you'd like. Now, if you want to do something like that, then in a sort of Python client, the system or the interface very quickly becomes clunky, right? So we deliberately avoid that with the simple client, and we're saying if this doesn't work for you, you need to write your queries manually, basically. And then we try and give you tools to massage the output so that you can assemble it into something useful. So that's the sort of philosophical break there. But there is no such thing for the system as a whole. As a user, I think if you get the Python client and you can explore, so since it's GraphQL, that means that all standard GraphQL tooling works. So you can explore the schema that way, right? Which will take you some of the way, I think.
Is there some way to get at the schema in terms of programmatically? You can ask.
Yes, so that's a standard feature of GraphQL is that you can introspect, right? So I think there is this special query called _schema or _GraphQL or something. Most GraphQL clients have that built in, including the Python one I showed. Actually, I didn't show it here because I wrote the query manually, but you can do that. There is one that is called Apollo, I think, which is the most popular one. That is sort of this query explorer. So you need to set it up so you pass the authentication with it, but that shouldn't be a problem, right? And with that, you can get the schema, and with the schema, then you can just explore. Which in a way is kind of like when you work with SQL, right? It's that you can get the schema or you can just explore the tables and the relations and then join them as well, right? So it's very deliberately trying to use standard tools where we can, and to not put any obstacles in there just because, right? So a lot of software, annoyingly, in my opinion, tries to be practical at the cost of being useful, because now you needed to do that weird, odd thing that you didn't think about, and now you're taking away my ability to do so, right, by trying to help me. And I appreciate the sentiment, but the result isn't what neither of us wanted. So, and that's why I think the separation is very good. But as very long-winded answer to documentation, not as much as I'd like. Eventually, we'll get some reader docs, complete structure with tons of examples and languages and whatnot. But until you have sort of the org backing and user base for it, it's just not a priority. The project has been changing very fast. So what we would have written a year ago would be all outdated now. Right? So that too is why it's because it just can't keep up. And honestly, wrong documentation is usually worse than no documentation.
Yes, it is. And introspection and actually asking the software for, its structure and stuff is the ultimate documentation.
And that's pretty cool too, because that means that you, so for instance, in Python and a lot of, especially the high-level languages, you can use these DSLs for selection, right? So you can, and that means that you can write very user-friendly software where you can almost from a checkbox say, I want this and this and this property, and you just build this into the DSL. But that's not something we want to do for you, because all of a sudden we get it wrong, and then at that point, you might as well just do it on the source library directly. If we would just wrap that and do nothing on top of it, then the only thing we're doing is obfuscation, right?
Yeah.
We don't like that. So yeah, as for documentation, I think that's it. Other than that, I mean, the team, they're pretty easy to ask, and they'll tell you pretty much anything. So it's been a bit pull-based, I guess.
Great. Cool.
All right.
Well, thank you. I just asked for anybody on the call have any additional questions?
Hi, this is Robert Witt.
Hello.
Hi, Robert.
Hi. I came in a bit late. I was prohibited from joining at the scheduled time. I had some questions posted in the chat. I guess they've been covered already, or?
Yes, but I can do a rerun if you'd like, because there might be a little bit more back and forth. And also now there's a lot more context for some of them.
Yeah, if you don't mind, then
I don't mind at all.
That would be great.
Yeah. So we just start at the top and then work our way down. Yeah. So the OSDU has a couple of post-SEG-Y initiatives already: OpenVDS from Blueware and OpenSEG-Y from Schlumberger. So how does Oneseismic relate and compare? Wow. I don't think either project should be considered an alternative to SEG-Y. It isn't. SEG-Y is for interchange and arguably archiving and not working. So in that sense, Oneseismic does more closely compared to OpenVDS and OpenSEG-Y than anything SEG-Y. I don't think SEG-Y was ever really meant to be a processing format unless you were doing straight up stream processing over traces, right? It's meant as an interchange format, and it shows. And obviously working on it from a geometrical perspective is just terrible. As to how it compares, I think the primary difference, because they're all very similar in some of the design choices with the blocking and all that, but I think the difference is largely in the intention, right? So OpenVDS is really a support library which knows about some structure remotely, and it allows you to use their library to query that structure, right? And it has its compression and decompression, which works like a wavelet, so you can gradually get higher and higher resolution, but even in the short reads, you get the quote-unquote full trace, right? That's all well and good, but that means that in order to read full resolution from the middle of the trace, you basically need to decode all of it. So that gives you almost tape-like properties for a single trace. OpenSEG-Y, I think, does essentially the same thing. Okay.
OpenSEG-Y or SEG-Y, the SEG-Y format was sort of known to compare favorably to SEG-Y because of using bricking. So,
yes.
So you're essentially catering for all the main 3 dimensions or reads in all the 3 dimensions.
That is sure. I still think it does the wavelet thing, but maybe on the individual bricks. So, excuse me. Oneseismic, on the other hand, doesn't so much care about the traces as much as it tries to be aware of general and interesting geometric structure, or geometrical structures, if you want to call them that. The slices, the moving curtains, horizons, right? So Oneseismic, I think, is more about the queries than about the data itself. So for one, this idea of query or getting columns kind of sort of doesn't really show in Oneseismic. So, but in OpenVDS, what you need to do in order to get a curtain is you need to essentially ask it for every single trace in that curtain as it is, right? And then that's a read operation, which it translates internally to a fetch, and it does all the downloading internally. Oneseismic does that sort of as a service. So the expensive operation, if you will, the fetching of the bricks, the managing of the bricks, all that happens server side. Whereas on OpenVDS, that happens client side, which means for users, it's much less network traffic. And I think it's a much nicer and more reasonable interface because it's less mechanical, if you will, in Oneseismic, right? That being said, you could have built something like Oneseismic on top of OpenVDS, right? But Oneseismic tries not to focus too much on the data format thing, and OpenVDS is all about the data format. Oneseismic, to a much larger degree, just tries to be sort of user, but programming user-oriented, and not so much about the files. Okay. I guess
sorry.
Same thing. It's all about the file, right?
But a lot of the complexity or the foundation for both OpenVDS or the thinking behind them relate to the fact that you're dealing with maybe volumes of terabytes of data.
Yeah. So do your query or Oneseismic is? Sorry, I missed the first hour of this presentation, so I'm probably not very well qualified to ask. But you say you're not caring about the data, but you must have done something to manage large volumes, right? No, not anything clever in particular. No, we just take the SEG-Y as it comes, and then we brick it, which just means that we have more efficient non-sequential access, right?
Okay, so it's SEG-Y in that sense.
Yes, and OpenVDS. OpenVDS does the same thing, but it has their waveletting on top of it, right?
Okay, cool, thanks.
But I mean, honestly, nothing clever, and it's astonishing how well it does work. But it does work because of the assumption that you only care about very localized stuff anyway, right? So obviously, querying a terabyte volume is slower, but honestly, so most of the times the terabyte volumes show up is because of exploration stuff, where either you have very sparse but large areas that you measure, or you have separate surveys that you just mesh together, right? And if you're in the latter case, Oneseismic is heavily biased to just store them as they're separate, don't pad in between, and do that in application, because querying different volumes now doesn't suck anymore, because you have to deal with large files, right? You just have to deal with tiny ID. So you can have your collection of volumes by just storing a collection of keys, right? Which is easy. And as for the super big ones, even then you still usually only care about a small subset at the same time, right? Obviously, then your slices are going to get massive, but you can get shorter slices by just doing straight curtains, right? Which is just segments of a slice. And that works well. I mean, the cost is linear to the data or the size of the output, right? And for the really bad cases, you can spin up more worker nodes and get more bandwidth, right? So, I mean, that costs money, but if you want to query fast, then that costs money, right?
You probably have the money.
Well, yeah, and it's pretty cheap still. It's honestly, I think it's a lot cheaper than the alternative. So, does Oneseismic support more esoteric variants, for example, 2D and 4D surveys, pre-stack offset gathers? 2D surveys, well, so the answer is yes. The geometry module that does all the fragment or brick mapping for us supports n dimensions. So that's fine. Most of the code now is written, most of it supports n dimensions, but there are some places where we essentially pin that n to be 3, right? Which is pretty easy to fix, but you still need to thoroughly fix it. But in principle, the format supports n dimensions, and most of it would. So when it's mostly post stack, you can make both 2 and 4D through 3D, and it's probably the most elegant anyway, right? So 2D is you pin one dimension to just set 1, and for 4D you store the volume separately when they're vintages, because there's just separate surveys, they just happen to be of the same area, right? And then since you can easily flex on the key, on the identification, then, I mean, doing 5 queries against 5 volumes is still fast and easy, right? So, but I mean, the format under there supports it. Off-stack gathers arguably is another case of just, I mean, it's very similar to vintages. So what you can do is you can split it into 3D and just query them separately, because what you want to do after probably varies as much anyway. But that too is conceptually supported, but implementation-wise not. Most of the implementation doesn't care, but a little bit does. Is round trip from SEG-Y to Oneseismic to SEG-Y lossless? Actually, we don't support back to SEG-Y at all. We throw away most of the uninteresting trademark header information, so you can't really reconstruct. To me, that's not the biggest loss. I know that's one of the features that Blueware prides himself with. I think it's overrated. It's super easy to sell. I don't think it's very valuable. I think you want to preserve the SEG-Y in its pristine format on some tape or something anyway, which means that, you know, the ability to reconstruct subs being interesting. And that comes at a cost in complexity in format and addressing and storage too, right? Because most of the headers, at least for post stack, aren't interesting at all, right? Because they're not meant for that. When it comes to data, we store the data as is in the SEG-Y, with the exception of we do IEEE translation. So we store the data as is in the SEG-Y. So we store them in full resolution. In principle, so the format itself has support for all kinds of compression and transformation and different resolutions. We just don't use that yet. Okay, but it's pretty easy to add. But right now, I mean, Oneseismic is built on the assumption that you want to do maths, and for maths you need full resolution, so you need to have that available and/or stored anyway. We try doing some stupid compressions on it, and it usually is a pessimation. So then you need clever compression, but clever compression in Seismic is an unsolved problem. And from our measurements, the CPU cost of compression and the CPU cost in the data center in general is so high that the benefits you would get from it is there are no benefits, right? It's just as fast without, and yeah, CPU is expensive.
Agreed.
Excuse me?
Yeah, I just said I agree.
Oh, yeah. No, in the format itself, there is support for it, but that's more for very special purposes rather than some general notion of compression. I think that too is an oversold argument in this day and age. So what's the underlying bulk storage mechanism? Most of Oneseismic doesn't care. Most of Oneseismic works with something is transferred as a chunk of bytes. Implementation-wise, this is and the protocol of what things are called and how they are related to some root is also storage independent. But it does assume something that looks like either a Unix file path or a blob or bucket file path, right? Which obviously are meant to emulate each other. In practice, we store one input survey, so one input volume, under this one key. That's our container in Azure terms. I think that's what's called a bucket in Amazon. I don't know what it's called at Google. And it allows us to set permissions on container level, which is where you generally want it. And under there, you have the manifest, which just lets you know what kind of formats are available, where they are, and how to look up, and some metadata stuff. And after that, we just store in a very predictable pattern just the blobs directly, right?
And those are the bricks, is it typically, or is it the sort of the sections of the? So do you have optimized storage for full inlines or cross lines?
No, just bricks, and everything else is resolved online. So what we started doing this week is we started caching like crazy. Right, so that's not really implemented upstream yet, but with caching on top of that. So if we just store the bricks and resolve, you can expect to extract from a 10 gig volume any slice really in about 400 milliseconds end to end, right? Which is, it's okay, but honestly, I still think it's slow, right? If you cache on top of that, we get into the maybe 100 milliseconds territory pretty fast, right? But I mean, going 4 or 5 times from cold to hot cache is still pretty good, right? Yeah, so we just store them as is. So one thing we do is that we have the ability to store the same volume at the cost of, storage space. You can store a single volume in different partitions. So for instance, if you know that for this volume in particular, you have some fields that are super large but super thin, right? So you typically want to do more of these either long horizons or just time slices on this thing, right? So if you know that you primarily want to do flat queries, then you can store flatter cells, which means fewer fetches. So you can do some of those optimizations, but we don't store pre-computed inlines generally. Yeah. There is room in the format, though.
Yeah, cool.
All right. I think there was one last question. Hang on. Yeah. But that's the granular. So we are independent in Azure terms of the storage account. We take that as a parameter because there are some limits on the storage account. Until we really get to those, we don't care to handle them. Right now, we're far away. And also, I think with caching, a lot of those problems go away.
With caching, you mean caching in memory on each node?
Yeah, pretty much. So right now, we have a pretty stupid scheme where we just cache everything until we run out of memory. Yeah. But it works okay, right? So that's fantastic. What's gonna be refined now. But we haven't hit a limit yet. I think proper production settings might hit that, and then we'll deal with the issues as they come. Because honestly, there's no point optimizing for that until you know what you're dealing with. Is Oneseismic limit to physically persisted array of samples, or is the notion of lazy compute with caching and pluggable algorithms? So Oneseismic attempts to solve the I/O problem and the I/O problem alone. we don't want to deal with compute. We want to make it so that a lot of the sort of free compute or lazy compute caching stuff would be either trivial or easy enough to handle, and that refetches should be cheap enough that you can just do them when you have to, right? We don't want to provide a compute product, although building a compute product on top of Oneseismic is pretty feasible. And honestly, I don't think it's that hard, right? Because it's just another storage system. But that's not our goal. Our goal is to make the I/O problem not obnoxious, and that's it, really. So I think that makes the product focused, and I think so. It's like in the sort of Azure or Amazon really story, where they started with their queue service, which is basically their only thing, and then they added S3 and they built everything on top of S3, right? And I think this should almost follow the same thing, is that you start out with Oneseismic, and now you have the storage thing solved, and then you build services on top of that relies on the properties of Oneseismic to do their interesting things. But that's not a goal for us at all. So it's all storing samples, for sure. Which is, because I think that's a very interesting problem, only because of its size, right? Because the underlying problem is not interesting and it's not hard, in a way. It's just large and it becomes complex because of its size. So it's very fascinating. Yeah.
Yeah, thanks. That was all the questions I had.
Yeah. Very good questions, by the way.
Thank you.
Yeah, I'm very happy.
Yeah, no, it's interesting. But I still, it's something we might want to look at, Oneseismic. But we're already investing quite a bit in OpenSEG-Y or in OSDU for that matter. So I'm on the OpenSEG-Y side at the moment, and then OpenVDS maybe towards the start of next year.
Yeah.
So my point is just that since we're already dealing with SEG-Y and one or maybe two other or more sort of modern storage technologies, and these are much more established than Oneseismic, I'm wondering how it can take off. But as you mentioned when I came in, it might have a special affinity with research or experimental work.
I think they can. Honestly, I think they can be complementary. Because if Oneseismic solves your particular problem better, then of course you would use it, right? And the same way, if what you're doing works better with OpenVDS, and go ham, right? Or OpenSEG-Y for that matter.
Yeah, it's not just a matter of solving my problem, but it's our clients, right? Who have a petabyte of seismic, and we are part of recommending their path forward into the cloud, migrating, sort of not digitizing, but moving SEG-Y to a more modern platform.
Yeah.
And then mixing and matching between OpenSEG-Y or Oneseismic or VDS for that matter will probably not fly, because even though storage is cheap, just willy-nilly duplicating files just because you want to play with Jupyter or
Chaps, I'm just gonna say that I'm gonna just switch off the stream now and things, and I just want to say thank you, Jørgen, for a great talk. And great, and so it's all offline now.